Welcome to Data Analytics Webinar 2 and the evolution of ETL and Databricks unified real-time and cloud native. So this topic we are going to cover as a renowned speaker and Lanka Kaudinya. He is a senior data engineer at Grid Dynamics, and he is going to give knowledge on the ETL and as well as Azure Databricks, how it will be get around and how it's going to work on the real-time activities part with some real-time scenarios with basic concepts too. So, Kaudinya, welcome. Welcome from the Data Analytics Group team. And can you hear me, Kaudinya? Hello? Yeah, just messaging. Kaudinya, can you hear?
Yeah, hi all, good morning. Today's session.
Hi, Kaudinya.
Hi Rajendra. I feel you are not audible.
Yes, I'm able to hear you. Thanks for joining and welcome to the Data Analytics webinar 2. And I just introduce yourself. Maybe just share your screen and you can start giving a session on the evolution of ETL and Databricks, which has been a cloud native part. Yeah, handing over the stage to you, Olivers. Yeah.
Thank you, Rajendra. So today's session is on the evolution of ETL on Databricks, unified real-time and cloud native. So coming to introduction about myself. So I have totally 7+ years of real-time experience. I have done graduation in electronics and commerce, communication engineering, and MTech in communication engineering and signal processing. So after that, I have worked in software in multiple areas of data engineering, data integration, data migration, data replication, engineering projects. So currently I was working as a senior big data engineer at Grid Dynamics. So these are some of the certifications I have done. And let's start with the today's topic, coming to the introduction and agenda. So the data world has seen many trends come and go. Some have transformed the space and some have turned out to be short-lived fates. So in the most recent world, without a doubt, generative AI is everywhere in the world. So we are speaking even it has involved in the national politics, also international politics. Everyone, government is also providing its support to the generative AI, and first time ever they also involved with the technology and they are promoting the generative AI. So at every turn, there's chatter about generative AI, LLMs, and chatbots. So a recent MIT review report shows that 88% of surveyed organizations are either investing in adopting or experimenting with generative AI. And out of that, 71% organizations intend to build their own generative AI models. So in the increased interest in AI, fueling major investments as AI becomes a differentiating competitive advantage in every industry, as more organizations work to leverage their proprietary data for this purpose. Many encounter the same hard truth after working the real-time projects in generative AI. The best generative AI models in the world will not succeed without a good data. That is what they had seen in the recent times. So this recent reality emphasizes the importance of building reliable data pipelines and that can ingest or stream vast amounts of data efficiently and ensure high quality data. So if you see in a generative AI project, we will have gather more amount of data because a project or any project which needs data. So without data, there is no such project success. So the data will be in many types and it is most recently we see that the data has to be in structured and it has to be unstructured, maybe in semi-structured, or the data will be in any format. Okay. But the data needs to be cleansed. The real-time data, how much of data is valuable and how much of data is cleaned and how much quality of data. That is what is important for a project to get success. So that's why the the data engineering part comes in the picture. So who gives the quality? So challenges of data engineering in the AI era, because the data has to be in multiple sources. In this, the first one is the data sources. Disparate data sources challenge most organizations. So in coming recent future, what happening is, so maybe the ISG has a predict that by 2026, 8 out of 10 enterprises will have their data spread across the multiple cloud providers and that on-premises data centers that span multiple locations. So getting the data from multiple cloud locations and getting the data from locations to bring the data to get the data to one place and do some operations on it. So definitely the generative AI to start their project, before that they have to get the data and collect the data from multiple organizations, because the generative AI will work on the training of the data. So any model, whatever you implemented on machine learning algorithms and deep learning algorithms, they definitely have training. So how much quality of data they are getting and how much data they are training. So they have to collect huge data. So for this purpose in market, the word is famous is for big data. So big data is nothing but a huge amount of data. We are collecting the data in multiple places like recently mobiles and streaming, and there are IoTs and sensors which can collect huge amount of data. So the multiple sources of data has to be collected, and this decentralization creates a dependency on specialized siloed teams. So inefficient pipelines and development which leads high cost and slow time to value, and computation also, which limits the usage of data and blocks innovation. So second part is the first is the data sources, second one is the handling real-time data. From mobile applications to sensor data on factory floors, more and more data is created and streamed in real time and requires low latency proficiency. So it can be used in real-time decision making. So definitely the real-time data has to be processed and has to be transformed, has to be cleaned up. So these activities has to be done by a data engineer or a data analyst who is helpful. So the third one is the scaling data pipeline reliability, because when the huge amount of data comes in picture, so definitely there for processing of this data, we need a scaling, because we definitely after doing many transformations or processing them to bringing some place to another, so we need some computation. So for this computation we need some memory and some memory processing, so which is nothing but cloud computing. So in recent times, so with the data coming in large quantities often in real time, scaling the compute infrastructure that runs data pipelines is challenging. So especially when trying to keep costs low and performance high. So running data pipelines reliably, monitoring data pipelines, and troubleshooting when failure occurs. So are some of the most important responsibilities of a data engineer. For example, if you are creating a streaming data pipeline, it has failed and it is continuously failing. So you have to do the troubleshooting the issue and you have to recover the data, and again the data for example for 2 GB of data is processing every hour. So for example a troubleshooting has happened and the system has failed for 4 hours, so 8 GB of data has to be processed, and additionally to that the 2 GB of data will comes every hour. So this is all what we have to see when we comes in picture of pipelines. So this reliability we have to provide in the times of scaling. So we have to do multiple computations, multiple calculations, how the memory, how much memory we need, how much worker nodes we need, and how much tasks we will run. So these all things we have to see. And the fourth one comes in picture is data quality, because data quality is very, very, very important term for the generative AI. Because recent projects, after implementing the real time, what they faced is because of data quality issues, the project is failed. Because the generative AI is simply provides the data, whatever is based on historical data. Because if the historical data is not correct, definitely it will provide a wrong result. So that's where the picture garbage in and garbage out. So high quality data is essential to training high quality models and gaining actionable insights from data. Ensuring data quality is a key challenge for data engineers, because if let me give a simple real-time example. We have a sensor. When we are doing the battery cars, is in the recent time we see many battery cars. So recently some data science projects came in picture to identify the battery anomalies, means how many of the cells are failing or how many of batteries. So lifetime prediction, aging prediction, these kind of things comes in picture for a battery car. So predicting the lifetime of a battery. So for calculating this, they definitely need the voltage and cell current and temperature, these kind of parameters from the battery. So we used to get the data from the battery car when it is running. So we have installed some sensors in it. So they used to send the data to cloud every 5-10 minutes. So we used to get the data, and sometimes we'll miss the data also due to some network issues or sometimes some issues. Sometimes it will be in skill down. So we have to calculate the data, and whatever missed data is there. So we have to predict the data as well. And we have to do the data cleansing. Sometimes we will get the wrong data. For example, voltage has to be 34. It reached the threshold and it was crossed, and after some time it came in up below threshold. So these kind of examples where the we have to do in real time, so data cleansing. So this is a major important thing in for a data engineer to handle the data quality for a when a project is going to be a generative AI or machine learning models we are developing. The fifth one is governance and security, very, very important topic, because when the data is in a cloud, so definitely we should have a security, because data is very important and it has to be very privacy. We have to maintain that. Becoming a key challenge for organizations that find that data spread across multiple systems. Means as we said, data sources will be multiple. So how to handle these kind of things? With increasing larger number of internal securing and governing data is also an important regulatory concern many organizations face, especially in high regulated industries. So these challenges stress the importance of choosing the right data platform by navigating new waters in the age of AI. But a data platform in the new age can also go beyond addressing just the challenges of building AI solutions. So the right platform can improve the experience and productivity of data practitioners, including data engineers, by infusing intelligence and using AI to assist with daily engineering tasks. But governance will also be a major important role, where multiple people will act touch the data, because for example data engineering team will touch the same production data analyst team will handle those things, and data machine learning team, data science teams. So multiple teams will approach the data. So we have to maintain the security for them, and we have to handle the things.
Kaudinya, sorry to interrupt. Your screen is showcasing introduction only. Is that correct?
Yes,
Same
it is
screen.
correct.
Okay.
Yeah.
Thank you. Yeah.
So whether your title is data engineer or another data oriented profession, we see you as an analyst or data scientist, recently data detectives or data governance people. You have likely heard the term ETL. There's a good chance ETL is a part of your life, even if you don't know how it is. So ETL is nothing but extract, transform, and load, but it will do many things. It was there from last couple of years, and now why we have to rethink about ETL today? ETL is used to describe the foundational workflow most data practitioners are tasked with. taking data from a source system and changing it to suitable their needs and loading data into a target. We want to help product leaders make data-driven decisions. It can build some platforms, critical tables for your reports. So ETL creates quality data sets, and ETL will bring process lineage and observability to your workflows. If you want to do anything with data, you need to be a reliable process or a pipeline you need, definitely. This fundamental truth holds true from classic business intelligence workloads to cutting edge advancements like large language models and generative AI. The recent fascination with AI, largely brought by the release of OpenAI's ChatGPT, extends beyond the media's interest and among researchers. It is now seen by many as an essential strategic investment, and who wants the left behind. The truth value in LLMs comes from embeddings or fine-tuning models to clean and curated datasets. So to bring a large language model, we definitely need a cleaned data set and curated data sets, because the AI models will be built on the existing publications which are there from the journals. So the journals will be made on the laboratory data, because the laboratory data will not be same as the real-time data, because in real-time data we will see many hallucinations and many fluctuations in the data. So we have to do the cleaning of data, and curation of data has to be happen. These techniques allow for the creation of models with domain specific knowledge, avoiding common errors like hallucination. See, why we have to need a domain specific knowledge to build a generative AI model? Because whenever we are building a model, for example, if we take a smaller project, if we are doing any CRM or ERP systems, definitely we have to know the sales structure. We have to know how the opportunity comes in picture, how the lead comes in picture, how the quote has to happen. So these small things we have to know for a simple data engineer or data analyst. But when it comes to the generative AI or data scientist, they definitely have to, the first and foremost thing to identify is feature. So the feature extraction will take a long of time, because which feature is reacting more. So that kind of feature we have to identify from that. So which feature will gives us more data. So that for that purpose, they used to do some confusion matrix and so many large language models and machine learning models. So like that, so many algorithms they used to try. For that purpose, we have to understand what type of data it is. For example, if you consider speech data, so in speech data, we have to see, okay, the waves, how it is going. It will be in the wave structure. So such kind of functional knowledge we need to build the data model for artificial intelligence. For that purpose, we should definitely have functional knowledge on it, and we have to work around on it, because without knowing it, how you knows, okay, we have to clean the data, this part, and how you knows which the data is needed or which data is creating the anomaly. Such kind of things we have to understand. So of course, meaningful embeddings are derived from cleaned data sets. In that sense, AI is built on data transformation. So majorly the AI will comes in data transformation. So data transformation is what happens in the cleaning of data and making a structured data and making the data perfectly for the model, which should not have any breaks or any creation in the data sets. So one might say extract, transform, and loaded, and it can be called as moved, mutated, and merged in a single solution. So a changing data landscape in this AI model is, in addition to the recent surge in generative AI, other trends have reshaped the data landscape over the past decade. One such trend is the increasing prominence of streaming data, because the streaming data will comes continuously. We have to do the cleaning and we have to do transformation. So how these things has happened? Because when we have to work with historical data, we have so much of time to analyze on the things, and we can predict the things, and we can do some analysis, we can do some calculations. After that, we can do the things. But when it comes to streaming data, we have to see fastly and we have to make the transformations fastly. Companies are now generating vast quantities of real-time data through sensors, websites, mobile applications, and more and more. This shift necessitates the real-time ingestion and processing of data for immediate decision making. So data engineers are therefore challenged to extend beyond traditional batch processing to construct and manage continuous pipelines capable of handling large volumes of streaming data. Another noteworthy development is the emergence of data lakehouse architecture. So this amalgamation enables the execution of both AI workloads and analytics workloads within a singular framework. So this has brought in the picture to bring the data analytics and the AI related workloads, machine learning workloads to the some same platform. While ETL is a long-standing concept in data management, its relevance remains undiminished in the modern data landscape. A critical consideration now is how ETL processes can adapt to encompass both batch and streaming data and how they can be effectively integrated within a lakehouse architecture. So this session is mainly aims to illuminate these aspects, helping you understand ETL in light of these evolving trends. So in this picture, we can see how the data warehouse and data lake and data lakehouse came in picture. So there is a lot of confusion because data warehouse is specifically used for the reporting people for data analytics. So it consists of columnar data and huge data. We will build star schema, snowflake schema, and data modeling, these kind of things. When it comes to data lake, it is for the people who works with structured, semi-structured, and unstructured to structured and data engineering purpose. These things are there in the real time, but there is a platform which comes to cover these both aspects in a single way is data lakehouse. The data lakehouse represents a novel concept seeking to merge the capabilities of data warehouses and data lakehouse, leveraging new storage technologies like Delta Lake, which enhances the reliability and performance of Delta lakes. The lakehouse model combines the cost-effective, scalable storage of Delta lakes with the efficient transaction processing of data warehouses. This amalgamation enables the execution of both AI and workloads and analytics workloads within a single framework. This integration significantly reduces the complexities associated with maintaining parallel architectures, ensuring consistent data to the governance and managing data duplication issues also. So there is a feature which involves the data lakehouse architecture to run is Delta Lake, which is a open storage framework. That brings reliability and performance improvements to data lakehouse. So the Delta Lake, which will work with ACID transformations and batching and stream data and optimizing the performance with JET ordering and data skipping. So when it comes to ACID transformations, which is nothing but atomicity, consistency, and isolation and durability. And this Delta Lake has so many features. It runs on top of your existing data lake and supports Parquet files. So when we create a Delta Lake table in any platform, so it will create two files in the backend. One is a Parquet file. It used to directly use it to store the data in Parquet. And one more file is created to capture some of the features which can help for further processing. So it can one important feature in Delta Lake is optimized reads and writes. So the benefits of Delta Lake are, so mainly we have to say time travel. What is a time travel? Time travel means here there is no future, only history we have. Okay, so in history, we have to bring the data from historical history, what we have done yesterday. So means we are maintaining the audit. So how the audit history will be maintained? That will be stored in one more file, what I told before. So here, when we see the time travel means, so whenever you created a table, a file is created, okay, this table is created with this schema. After that, you load a data to the table and it will write that as well. After that, you will do some operation because it is simple to do any operations easily with single query. Once we update a column and later we will update another column, but storing the history when comes in picture. So how much memory it has to store. If you want to bring that version, you want to go with whatever version you have done previously to get that. So how much history it has to store. Against memory storage issue will come in picture. So this time travel is a feature which is enabled for limited period of time. It depends. When it comes to Unity Catalog, there are some features. When it comes to managed and unmanaged, there are so many features in it. But maintaining the history for some period of time, for that to enable it efficiently and performance wise, the picture comes in picture is optimized reads and writes. So if you've done multiple writes, so the final write will be considered as an optimized write and it will be stored in history. And if you've done multiple reads on a data, that in that only final read what you have done that will be stored like this it used to do. And the one more feature is optimized jet ordering, which will help in searching the data fastly and filtering the data fastly. Such kind of features it consists of. That's why the Delta Lake is very efficient and performance wise more and less memory. So these are the features. Like one of the more important feature is unified batch and streaming is also one feature in Delta Lake tables. So the next is many people have a doubt that ETL, some people will say ETL, some people will say ELT. So what is ETL and what is ELT? So ETL is nothing but extract, transform, and load. The other is extract, load, and transform. When we have to use ETL. So ETL use cases mainly are financial reporting systems, data warehousing for business intelligence, and applications with limited storage or compute capacity. So when we worked with on-premises systems, many of you, I think, worked with on-premises systems like SSIS and IBM Data Stage. Some people are working with Informatica, TAL, and Apache Nifi. These are the use cases in ETL use system. So when the cloud comes in picture, the definitely for a huge amount of data, we'll go with ELT. So ELT will be like for big data analytics and machine learning pipelines because huge amount of data, streaming data will comes in picture. So for computation of this data, for doing transformation with the existing source systems, it is more compact. So to achieve this, we are using the ELT. First, we will load the data to a data lake cloud related storage. And after that, we will process these things. So scenarios with high volumes of semi-structured or unstructured data. So to bring that structure, so this for these applications, we will definitely go with ELT. Anyways, it is ELT or ETL or LTE. We will call it as ETL. The next picture will be the key components of cloud native solution. Because when we comes to the cloud, so there are multiple features which consists of which can help us. Okay, first is data sources. Data sources, there are various data sources we used to have, such as databases, APIs, and streaming platforms. So many data sources we have to inbuilt them and we have to bring them to the cloud. That is first part. And second is data ingestion layer. So when we talk with ELT process here, so we have to bring the data, whatever there in the on-premises system, to exactly to cloud, and we will store the data in the responsible extracting data from sources and loading it to the cloud environment. The third one is data lake and storage. So a scalable repository which will store, try, and process data, often using technologies like Azure, AWS storage, or GCP, S3. When we consider with Azure, it is data lake, and when we consider AWS, it is S3. So these kind of things will help us in storing the data. After that, what is the important feature is compute engine. So when we see the compute engine, so it is completely cloud-based compute engine. So when we are processing the data, so we will have to calculate how many worker nodes we need, how many driver nodes we need, and how many CPUs we need. So these all will what type of computations we used to perform. So these all things will comes in picture. So to calculate that computing clusters, so we are using Apache Spark or Hadoop. I think more than when compared with Hadoop and Apache Spark plays a vital role because it has inbuilt processing with storing the data. So the next one is orchestration. So this is a very important where we have to coordinate this all process, entire process of bringing the data from on-premises or different kind of sources to the ingestion, and after the storing the data, after the doing transformations and coordinating with the compute clusters. So these all things will involve in the proper perfect orchestration. We have to do this. and which can coordinate the execution of ETL workflows and pipelines. Next is the monitoring and logging. Tracks the performance and health of the ETL processes, debugging and audit logging, and how to log the things and how to debug the things when a system has failed. And final and last one is the security and governance. When it comes to cloud, definitely our data has to be secured and it has to maintain privacy. So how the data is protected and how the data access will be provided and how the governance will help in picture with the help of compliance with regulations. When it comes to healthcare, we will see the HIPAA or GDPR, such kind of things. So what are the advantages of cloud native solution? First is the scalability, because we can, when we are working with an on-premises system, so we will face so many. To increase the scalability, we have to increase the memory. So we have to buy new memory disk and new processing. So it's purely very difficult to work with the on-premises servers. So cloud resources can be dynamically scaled up or down based on the processing needs and ensuring optimal performance during peak loads. Because when we see the peak loads, we will have some time now off time, we don't need that much load. But when we work with on-premises system, definitely we should maintain it. But when it comes to cloud, it will be very useful, because whenever we need the data, then we will increase our load, and whenever we don't need the data, we will turn off it. And it is a cost effective also, because everything in cloud is a costly. And second one is the flexibility. So cloud native solutions can easily integrate with a wide range of data sources and technologies, adapting to change business requirements. So third one is the cost effectiveness. Everything is a pay as you go model in the cloud. So we have to be very careful, and we have to be very design when we are designing a cloud native solution, we have to be see the how the resources what are needed, and on demand only we have to take the resources, and which will lead to the significant cost savings compared to the on-premises solutions. So its fourth one is the reduced maintenance. Cloud providers manage the underlying infrastructure, reducing the burden on in-house IT teams. For example, if you have an on-premises system, definitely you should have to reach your IT guy, and he has to provide you solution. You cannot involve any other guys. But when it comes to cloud, definitely the cloud provider will help you out in resolving the issues, and they will take that responsibility. You don't need to take the responsibility. You can just create a ticket and support him. And fourth one is the advanced capabilities. So cloud platforms offer easy access to cutting edge technologies like machine learning and real-time analytics. So whenever your on-premises project needs to be go with some advanced structure, so definitely you should buy the things. For example, if you are running an on-premises system with Python 2.0, if you want to build some new feature, so definitely you should need Python 3.0. You have to buy it and you have to install it. But when it goes to cloud, it can be easily upgraded to the new systems and new softwares easily. And global accessibility. If cloud-based ETL solutions can be accessed and managed from anywhere, facilitating collaboration across geographically dispersed teams. And final and last one is very, very important one: disaster recovery and high availability. So cloud providers offer robust disaster recovery options and high availability configurations, ensuring business continuity. So let's come to the main topic of our today's session, that is Databricks. Why we have to use Databricks? What is the use of Databricks? This Databricks is built on the data lakehouse platform, and it supports the cloud solutions like Microsoft Azure, AWS, and GCP. That's why the Databricks is very, very now for useful, and the platform where it is providing multiple services like visual ETL and data ingestion tools and data providers and business intelligence and for machine learning and centralized governance and top consulting SI partners. These many platforms are working on Databricks, which is an unify your data ecosystem and open source standard and formats. And this Databricks is built on the Databricks Lakehouse platform, which is built on the Apache Spark. And this has a reliability with Delta Lake at unified workspace for teams. And the collaborative workspace interactive notebooks support multiple languages like SQL, Python, R, and Scala, and PySpark, and enable real-time collaboration among data scientists, data engineers, and data analysts and machine learning people. The data lake integration built-in support for data lake enables ACID transformations and delta lakes and improving data reliability and performance and security. The ML flow integration is one of the features which is enabled in Databricks, which navigate integration with ML flow facilitates the end-to-end machine learning lifecycle from experimentation to deployment. And the final and last one is the data governance and security. Comprehensive security features, including fine-grained access control and audit logs, ensure data protection and compliance. And the most important thing is Databricks is built on the Apache Spark distributed computing. So the capabilities to process larger scale datasets efficiently, managed Spark clusters, automated cluster management, simplifies the deployment and scaling of Spark environments. So the distributed processing feature in Spark, which helps in in-memory processing, and DAG, which is nothing but directed acyclic graph execution engine, enables fast, parallel, and data processing across large clusters. And the optimized inputs and outputs. So Databricks implements various input and output optimization such as data skipping and caching, and to enhance performance when working with large data sets. And it provides Spark SQL, so which provides an SQL interface for data manipulation and data analysis, making it accessible to a broad range of users. The fourth one is the Spark structured streaming. So enables real-time data processing and analysis with a unified API for batch and stream processing. So these many features which supports the Databricks to be a platform used by multiple people across the teams. Let's see the Databricks architecture. So the Databricks architecture mainly consists of control plane and compute plane. So in the control plane, what it consists of: Databricks web application, notebooks, jobs, and queries, and cluster manager. So when it comes to compute plane, it consists of storage of the data, tables, and files, and the clusters. Let's see the features of Databricks. So the Databricks is an unified interface. Why it is called as an unified interface? Because it is a one architecture for integration, storage, processing, governance, sharing, analytics, and AI, and one approach to how you work with structured, semi-structured, and unstructured data. One end-to-end view of data, lineage, and power provenance, and one toolset for Python, SQL, Spark, Scala, and R, and which supports a notebook, which where we will write the code, and IDEs, and batch, and streaming data. So these all are the main features why we will call the Databricks as an unified interface, which can support business intelligence, streaming, and data science, AI, data warehousing, and orchestration perspective for all the cloud providers. And it can provide various types of sources data to consume to it, like Google Drive, Salesforce, and SQL, and dynamic CRM, like structured data, semi-structured data from different kind of platforms it can support. Like Databricks can integrate with multiple data partners. We don't need to worry about when we are working with Databricks, customer comes up with, okay, I have this tool, so we have to integrate this data from here to here. So Databricks can support easily with the help of delta sharing feature, which can help us from multiple sources and multiple platforms. We can bring the data. For example, if you see the data governance and security, which have multiple tools in market, so they all can be used in Databricks. And comes to the data sharing, so which can help the data sharing profile protocol which can help to share the data across various platforms and get the data from various platforms. And it can support multiple Gits, clone repositories like Azure DevOps, GitHub, and Bitbucket. And the important feature of Databricks, which has provided us the security and trust for the customers, is Unity Catalog with data governance. Because multiple people across the multiple platforms will use the data. So how you will secure your data and how you will provide trust for the customer that your data is secure and it cannot be shared with multiple people. And when in a project, we will work with multiple tenants. The data should not be shared between the tenants. So for this purpose, the Databricks brought a feature called Unity Catalog. The Unity Catalog will support the data engineering and governance teams benefit from an enterprise-wide data catalog with a single interface to manage permissions and centralized auditing. So automatically track data lineage down to the column level and share data across platforms, clouds, and regions. A rich ecosystem of data solutions, the data intelligence platform is built on open source technologies and uses open standards. So leading data solutions can be leveraged with anything you build on the lakehouse. A large collection of technology partners makes it easy and simple to integrate the technologies you rely on by migrating the Databricks. And you are not locked into a closed data technology stack, because when we work with some workspace and you want to switch to other workspace, you don't need to bring the data tables or data platform, whatever you structure you are given, data model. This Unity catalog will help us with work with multiple workspaces, multiple teams, because a data engineering guy will touch some part of data and data analyst will touch some part of tables. Like machine learning team will prepare the data from what data engineers and data analysts will do by using the training and for testing the models. So this data governance will help us provide the permissions for each level, each user. So it will be divided in 3 layers: catalog, schema, table. So these 3 layers will help us to divide who user is and who is the user, what is his needs. This is the one of the important feature where the Databricks now stands in the market, is which is with working with batch and stream processing in a single platform with Delta Live Tables. So this Delta Live Tables is a declarative ETL framework that helps data teams simplify and make ETL cost and effective in streaming and batch processing. So simply define the transformations you want to perform on your data and let DLT pipelines automatically handle task orchestration, cluster management, and monitoring, data quality, and error management. So engineers can treat their data as code and apply modern software engineering best practices like testing, error handling, monitoring, and data pipeline observability, automatic deployments, and operations. So the unified data orchestration with Databricks workflows offers a simple, reliable, and orchestration solution for data and AI on the Delta Intelligence platforms. So in this structure, you may notice one more feature is involved in it, which is hidden. So one is that is medallion architecture, which is famous in this Databricks Lakehouse and any other platforms also. This medallion architecture, which consists of 3 layers. One is the bronze layer, second one is the silver layer, and third is the gold layer. So the bronze layer, which is nothing but whatever data sources we used to extract from different kind of sources, like some of them are on-premises structured data like SQL or Oracle, some systems, and some source files like Excel, CSV, JSON, and some streaming data which comes from through API and from Apache Kafka, and Flink. We will bring the data exactly and what it is there from the source to the bronze layer, and we will store the data. And after that, we will do some data lineage or data transformations and data cleansing activities on the bronze to silver, and we will create the cleaner data sets in the silver zone. And from silver zone to gold zone, we will create whatever data we need for further processing. So such kind of architecture is also involved in this structure. So the next is the optimizing the data ingestion and storage. So efficient data ingestion and storage are crucial for the performance of real-time cloud ETL processes, where we have to use some features, because the data engineering team now have the majorly with the help of data intelligence, which is providing by Databricks. Now they have only two things where they have to consider. One is the designing of a perfect solution which can be memory optimized and performance optimized and cluster optimized. So to achieve this, we definitely need some features like using of Delta Lake for the using of Delta Lake for schema enforcement, ACID transactions, and time travel capabilities, how to use with the proper data reliability and query performance. And the second feature is implement autoloader. So autoloader is one of the best feature which can helps in Databricks is for efficient scalable ingestion of new data files. Because whenever we are doing some integrating the source systems or any Excel files or storage related things, Parquet files or ORC files from a storage. So this autoloader helps us to load the data as a stream from the storage systems easily to the Databricks, whatever the data is incremental in the storage without any feature we are handling. So it can handle automatically. The autoloader will work on majorly on the checkpoint feature, which is helps us storing of what data last it is stored and what type of schema it is storing. And the third one is the partition data effectively. So designing a partition strategy that aligns with common query patterns to optimize the read performance. Whenever you create a delta table, you definitely have to do some partitioning on the table, which can help you out when you are reading the data or when you are retrieving some data, when you are doing some filtering or when you are preparing some model. So it can bring the data efficiently. When you are using the delta lake, here the partition pruning or predicate pushdown or optimizing with G, these are the features which can help you to bring the data fast and reliable when we are working with a large volume of data. So leverage data skipping. The use Z order skipping in the delta lake can improve the data skipping and query performance also. And the final and last one is optimize file sizes. So when you are storing the data, so you should not store the data on all the data to a single storage file, which is more than 2 GB or 3 GB. So you have to leverage the data storage parallelly with the help of, there is one command in Databricks which can help us, the optimize command, so which can store the data. And there are some Spark features like partition and coalesce, which can help us to store the data equally and in all the files in the all RDDs or data frames. So the next one is the use compaction. So regularly compact small files to reduce metadata overhead and improve query performance. Because what happens is, if you are creating multiple partitions and which are being stored in small files, so multiple bringing the data and reading, when you are trying to bring the data, it has to read all the small files and it has to bring the data. So which will increase the memory processing. So to avoid that, use the compaction technology regularly. And next is the implementing effective data transformations, because the data transformations play a vital role for a data engineer. How you are utilizing the existing tools and how you are leveraging to it, that is more important. So when it comes to Spark SQL, so here we have to leverage the Spark SQL for complex transformations, taking advantage of its optimized execution engine, and implement broadcast joins. So what is this broadcast join? So when we are using the broadcast join means, actually when we are joining two tables, one is a large volume of data which is divided in multiple RDDs, and one is a small lookup table which consists of 10 to 15 or 20 or some small volume of data. So if it has to join, it has to create each RDD and each perform. So instead of using it broadcast join, which can divide to each RDD or each large volume of data partition, and it will create the performance and it will improve the fast execution of the query, and it can reduce the data shuffling also. But this broadcast join is also a performance issue when you are using the data for that broadcast join is more. So that also we have to consider. These all things we will understand when we are implementing in a real time. The next is the leveraging of Windows functions. So use Spark Windows function for efficient time-based and partition aggregations, because Spark provides multiple window functions like row, rank, dense rank, so which can help us for the calculating effectively, and which can gives us so perfect calculations and dividing the data sets parallelly and based on some filters. So these are what we have to use in their computations. So one, fourth and fifth is optimizing UDFs. When custom logic is required, so definitely you have to define your own user-defined functions. So how to define it and how to make it optimized with the help of Spark. That is what you have to consider. And when we are using the Databricks Delta Live tables, so which can implement continuous data transformations using Delta Live tables for improved reliability and specified management. Last one is the leverage ADF mapping data flows. So for less complex transformations, use ADF's Visual Data Flow Designer to reduce development time. So we have to use the Databricks parallelly with other tools also, which can help us and which can make things easy and faster. We have to do an analysis on which things can help us faster and which things can help us more performance.
Kaudina, there is a query in the chat. Can I ask right now?
Can I come to
Uh,
last?
Fine.
I will
Okay.
take I will take
Yeah,
the things at
fine.
last.
Yes.
Thank you.
Okay.
So next is the challenges facing with clusters. One is the time consuming management. So configuring and managing compute is especially selecting the correct compute and type for a specified workloads as long based on a challenge for enterprises, taking up time that could be spent on core business goals. So time consuming management on with clusters. And second thing is costly ideal time. So majorly of the time our processes we will not get any data, but the cluster has to run. So this is also one issue when we are maintaining with clusters. The third is the inefficiency. Sometimes the manual infrastructure management is often inefficient. For example, teams using manual methods may over provision compute and end up paying for capacity they don't need for user. So that inefficiency we will see in the clusters. And fourth is the slow processing. Sometimes compute will go to the infinite and it consumes all the memory and all nodes are occupied. So then we will see the slow processing and it is not ready to take new jobs or new tasks. So that is also one major facing challenge what we will see. And fifth one is the inability to scale. So without advanced auto scaling infrastructure, capacity does not match up with demand. Developers can't just focus on anything, and how we can't they cannot predict how the need is there and how to do auto scaling these features. And last one is the service disruption. So whenever a service disruption occurs, so definitely we will see a downtime in the clusters and we will face so many challenges because our jobs will go into pending when it comes in working back state. So definitely it has to execute all the pending jobs and it has to execute the upcoming jobs also. These are some of the challenges facing with clusters. Whoever using the Databricks so far, everyone can face these challenges in clusters. And to upcome this feature, so the market has came up with Databricks in recent version. So they came up with serverless compute on Databricks. So what it helps us? So Databricks now is a fully serverless enabled platform. So offering serverless compute for ETL workloads, including jobs, notebooks, and Delta Live tables, as well as Databricks SQL and machine model serving on AWS and Azure. It offers fast, simple, and reliable service enabling organizations to move at the speed of business, focus on delivering value rather than managing infrastructure. What are the benefits of a serverless compute? We will see, because it is so now if you are using a serverless compute, it can help us in avoiding whatever time we are focused with how much of memory and how much of nodes we need and how much of driver node and worker node capacity and how what type of technology we have to use. These all things will be handled by the Databricks core team. So the benefits of serverless compute usage is first is the performance. So serverless compute on Databricks provides superior performance that is fast, simple, and reliable. With instant and elastic compute, we will no longer have to wait for infrastructure resources. Serverless compute for DLT pipelines estimates cold starts and improves throughput and provides more efficient transformation. And second feature in these cost savings. So when you see the serverless compute and server compute, so there is a cost reduction of 25% or more than that also will get reduced when we are using with serverless compute, because whenever there is an ideal time, so we don't need to shut down our clusters manually. Automatically the management will move to them, right? So that's why whenever we need, we will take it and we will use it. And the fourth one is no management overhead, because serverless provides a fully managed service, eliminating the burden of capacity management and patching and upgrading and performance optimization to the cluster. So when it comes to upgrading, so currently we will use with Apache Spark 3.5. Now the on market Apache Spark 4.0 came in picture. So we don't need to upgrade our clusters, and we not need to upgrade our languages also, Python or Scala related things. So these all things they can handle up. And the fourth one is the speed. Compute starts up in seconds and not in minutes, because when you work with it currently with server architecture, so you will see when you are created a workflows like a job cluster, so definitely it used to take more than 2-3 minutes to start. But now with serverless architecture, we will see the Databricks will start in seconds, and Databricks runs warm pools of instances so that compute is ready when teams are here. The reliability is one of the important feature. So Databricks serverless compute shields customers from cloud outages with automatic instance type failover and a warm pool of instances buffering from availability of shortages. The scalability feature. So when it comes to scalability, Databricks intelligent serverless autoscaler automatically scales workspace capacity in graduated steps to meet demand, ensuring that workspaces will always have the right amount of time. So this is one of the real-time project design what we have done in the recent project. So here we have designed our system with the multiple sources like RPA management services and SFTP, Delta sharing, and Azure files. We used to get the data from different kind of things, and there is on-premises also sources like SQL Server, Oracle related things. And from there, we used to store the data to the storage accounts and function apps and Azure Synapse Analytics, which will help as a pre-ingest model. And after that, so from the integrate to pre-ingest, we have used the Azure Data Factory to store the data to the storage accounts. And after that, we have used the Azure Databricks autoloader feature, which can incrementally load the data, whatever the new data comes in picture in storage accounts. So it can take handle of the data and it loads the data as it is to the Databricks. And after that, we have created a Databricks Delta Live tables and workflows in Databricks, which can help us to in the form of medallion architecture, which consists of bronze, silver, and gold. And after that, we used to save the data in Data Lake Storage Gen 2 as a Azure storage network we are using here. And with the help of Delta Lake, we used to store the data in the Data Lake Storage Gen 2. And after that, our users are Power BI, and we used to share that models to the machine learning team with the help of Delta sharing. And these are the our structure what we have defined. For this structure, we used the data governance strategies like Microsoft Azure Entra ID to secure login and Azure Databricks Unity Catalog, which can help us volumes and storage of data and creation of tables with the help of Unity catalog. So which is consists of 3 layers: Metastore, Workspace Admin, and Users layer. So in this catalog layer, we used to create catalog schema and tables. Like that, we used the catalog feature with the help of data governance. And after that, we stored the data in Git repository of DevOps. And we have stored our privacy information in key vaults, and we use the Azure monitoring tool for monitoring these Databricks and cost related things with the help of monitor tool. And we have created some alerts as well. And cost management and billing will be provided by Azure, so which can help us to monitor how the cost and how it is going in future for each resource level. So this is a real-time project what we've done using this Databricks and Delta Lakehouse. But it is not so easy to design a project as we are seeing here, because we will see the data. Sometimes they will come up with, okay, so we will started with this project with on-premises sources only. After that, they came up with, okay, we have some API storage also. We used to give the data in API, and we again added this API management service. And after that, they came up with, okay, we have some storage networks. So from there also you have to build the data. Luckily, a Unity catalog will provide external storing and external loading as well. Okay. So these all things in design which will change when we are doing the development process because of using this Databricks feature. So easily we had integrated with every new feature and we have worked on it easily. So let's see the comparison between the Databricks, Snowflake, and Informatica and Talent, because all of these features will more or less provide some of the uses for the real-time purposes. So when it comes to data processing, so Databricks can provide best in the compared with all these three, and it can provide with the help of Apache Spark based processing and enabling high performance analysis and ease of use as well. So Databricks can be easily interact with notebooks with multiple languages, where with which language you are familiar, you can use it easily. And comes to integration capabilities, so it can integrate with any cloud services, so and open source tools and enabling seamless ETL with a wide range of sources. And scalability, best scalability design it can provide, and leveraging Apache Spark's distributed computing power to handle massive data volumes and high concurrency. And if you are using the serverless architecture, so you don't need to worry about these things. Only you have to worry about only two things when you are designing your Databricks solution. So definitely it has to be processed with all the latest features. Means it has to use less integrations or less transformations. So how to design effective solution for utilizing the existing features and how to use less transformations in your design. So whatever solution you have provided, you have to compare with other solutions with the within the market, and this solution is providing with us as a best in the wise of performance and in memory processing and computing. This can give us a cost efficiency, because when you see, when it comes to cloud, it is a play as you go. So you have to pay for everything, because so far when your customer or client is working with on-premises system, it's a one-time investment. So he has to invest on all the servers and he has to work on them. But when it comes to cloud, it is a pay as you go. Every month he has to pay the bill. So definitely your model or your workflows, your solution has to be convincing to customer that our Databricks, when we are using a Databricks, okay, it is supporting these features. With this help of these advantages, I had built my solution, which is helping us to get a more efficient performance. So these are some of the additional resources to go through the Databricks and which can help us to learn more things about the things. Ajendra, can you repeat the question what they have asked?
Yeah, yeah. From Meghana, can we use cloud in Databricks? If yes, how to pull data into it? Is it possible in Databricks Community Edition?
Yes, we can pull the data using cloud, but I think if you are using the community edition, I don't think so you can pull it, because you have to take the Azure account or AWS or GCP account to pull the data. Okay. And from there you have to create your Databricks community. Okay. Directly, if you are taking the Databricks community edition, you cannot take connect with cloud. Okay.
Meghana, I just unmuted. You can speak also.
I think if you work with Azure cloud, okay, as you asked with, is it free? So when you are working with Azure cloud, Azure will provide $200 for you when you are connected with credit card bill. Okay, when you connect with credit card, you can get Azure Databricks and Azure resources easily for free. Okay, with that you can work with Databricks.
Yeah, thank you for answering my question. Is there any library to pull the data into that, like Boto 3 library for AWS we have, right? So something like that we have, or we have to use, we have to create account and pull the data.
Yeah,
Is it free
definitely.
or
No,
free
no,
or
no.
something?
Yes, yes. So as you are using any cloud account, definitely you have to pay something for the cloud. Okay.
Okay.
So the cloud account will be created based on their fee. Okay. From the cloud account, you have to connect to the Databricks either with Mount approach or with Unity Catalog approach. So in the Unity Catalog approach, we will have volumes. Okay. With the help of volumes, we will connect directly to the cloud storage. Okay.
Okay,
It's an
got it.
external
Thank you.
connection.
Yeah. Any other questions, miss? Please post it in the chat, or else maybe just raise your hand so that I can unmute. You can speak.
Okay, these are some of the key takeaways when we are working with Databricks. So which can help us streaming between Delta tables is supported only in Databricks runtime 11.3 above. So now currently I think Databricks is working with 16 version. And if you use Spark SQL, dataset checkpointing lineage is not captured. So definitely to get that, you have to use the PySpark or you have to use the Unity catalog. And lineage is computed on a 90-day rolling window. So in this 90 days only, we can see the lineage. Means what is lineage means? It is the connection between your tables. So how many tables you have created and how the structure is created. So it is automatically created when you connect with the tables and when you write your notebooks in Unity Catalog. So you don't need to create a separate data modeling tool or data lineage tools like Erwin Studio or ER Studio. So this can help us. And if a table is renamed, lineage is not captured for the renamed table. That is also one feature we have to see. And Scala, R, and workloads using Databricks runtime for machine learning are supported only on clusters using the single user access mode. But now as we are going with the serverless architecture, so they can also be supported in Zoom. Bucketing is also not supported here as in AWS, like in other tools, but here where it is supporting the partitioning of data with the help of RDD feature, resilient distributed dataset, we can handling that feature. And writing to same path or delta lake table from workspaces in multiple regions can lead to unreliable performance if some clusters access Unity catalog and others do not. So here, when we are using with Unity catalog, definitely every workspace has to be inbuilt with the that Unity catalog only. Some has to work with Unity catalog and some should not work. This kind of things will not work in here. So to support that, we definitely have to see, okay, all in the every department in this project has to work with Unity catalog or not. And it can support to only region based, because when you are working with US East region, so Unity catalog is created, you cannot pull the data or you cannot pull the tables to other region. So only one Unity catalog meta store will be created in each region. And custom partition schemas created using commands like alter table add partition are not supported in the older versions, but now we have to take care of this feature in the latest version in other different way. And overwrite mode for data frame write operations into Unity catalog is supported only for Delta tables, not for other file formats. You can store the data in other file formats like Parquet, ORC, or any XML, CSV, and Excel is also supported in Databricks. So, but Unity catalog is supported only when you are going with Unity catalog. You have to see that Delta tables is created, and the Delta table will be stored internally with Parquet file, and there will be one more file will be created with ORC, which will take care of the cluster and schema. And Spark submit jobs are supported on single user access but not shared clusters. When you are using the Unity catalog, definitely you should have a cluster which consists of SQL warehouse. Okay, that is more important. You have to see when you are taking up these things. So in Databricks runtime 13.1 and below, you cannot use Python UDFs, including UADFs and UDTFs and Pandas on Spark. Okay, when you have to see when you are working with Databricks, which version you are working and what are the limitations to it. Okay, based on that you can use, because in the recent features only they have came up with the merge concept also. In older version, when I worked with 2 years back, we did not see the merge. We have written our own merge statements. So merge is nothing but which will do the insert and update operation. And audit logging is supported for Unity catalog events at the workspace level only. So it will not support at Metastore or admin level. And finally, with this session, I will conclude that as organizations strive to innovate with AI, data engineering is a focal point for success by delivering reliable and real-time data pipelines that makes AI possible with the Databricks platform, built on a lakehouse architecture and powered by data intelligence, and data engineers are set up for success in dealing with the engineers and critical challenges posted on the modern data landscape. So by leaning on the advanced capabilities of data intelligence platform, data engineers don't need to spend as much time managing complex pipelines or dealing with reliability, scalability, and data quality issues. Instead, they can focus on innovation and bringing more value to the organization. So when we are working with this Databricks new features, so definitely you have to focus how a solution will be more advanced and how it is utilizing the Sparks and how many jobs it is consuming when it is executing. Such kind of features you have to consider and you have to focus more on them.
Yeah.
This is what you have to learn from a Databricks perspective. Any questions, Rajendra?
Yeah, I'm just checking. As of now, no. And guys, if you have any questions, please post it. And I already provided the LinkedIn account for the speaker, Kaudinya, so you can get in touch with him. Maybe if anything on the Databricks related. And Kaudinya, I'm just like to thank you from our data analytics group community platform for sharing your thoughts and for sharing your insights on this, which is a truly engaging and thought-provoking for us. To every attendees who ever joined, thanks for your participation and your questions. And feedback form I just provided in the chat box. Please share your feedback, which will be help us to like engaging further.
Yeah, thank you, Rajendra,
Yes.
and thank you the
Yeah, thank you.
organizers.
Thank you. Thank you. Thank you so much, Kaudina. Thanks for speaking with us. Thank you.